This experiment involves highly corrosive materials. Proper safety equipment such as goggles and gloves are absolutely required. Wintergreen is a nice minty smelling oil naturally produced by many plants. Most notably, it is produced by wintergreen trees, which is where it gets its name. Wintergreen has a multitude of uses, such as its use in flavoring in candy and gum, its use as an antiseptic in Listerine, or for treating joint pains in products such as Bengay. One interesting thing about wintergreen is that when it is mixed with sugar, dried, and then crushed, it exhibits triboluminescence. This is when light is generated through the breakage of chemical bonds, specifically when the material is ripped, scratched, crushed, rubbed, or pulled apart.
Damn, son, where'd you find this?
Oh! Oh my god!
Wow.
It's the mother
We showed you in the previous video how to extract acetylsalicylic acid from aspirin tablets. But it uses lots of solvent and it's difficult to get a lot of product. Salicylates are useful compounds, and luckily there's another very OTC source of these compounds. Oil of wintergreen, which is methyl salicylate, the methyl ester of salicylic acid. As you know, esters can be hydrolyzed back to their corresponding carboxylic acid and alcohol either using acid or alkali conditions. We couldn't find a good video showing you the procedure for alkali ester hydrolysis, and since we need some salicylic acid for an up-and-coming reaction, we'll show you how it works. Here's 100 ml of methyl salicylate, which is about 120 grams of starting reagent. It's got a really nice slightly sweet menthol-like aroma. To perform the hydrolysis we'll need an aqueous mixture, so we've measured out 200 ml of water. Ultimately this reaction involves breaking the ester and adding water back in, so water is also the reactant. Next we've weighed out 47 grams of solid sodium hydroxide. This is in excess of what we need and corresponds to a 1.5 molar ratio to the methyl salicylate. Unlike an acid hydrolysis, the product of this reaction isn't the free carboxylic acid, but the sodium salt. But this is pretty easy to convert back to the acid, as you'll see later on. Okay, let's get our water stirring. And we'll add the sodium hydroxide. It dissolves very rapidly, but gives off a lot of heat in the process. We've got a nice clear solution now, so we're ready to set up for the reaction. We've got the 500 ml flask equipped with a magnetic stir bar, sitting on a hot plate. First thing we're going to do is add our warm sodium hydroxide solution. And now our methyl salicylate oil of wintergreen. What is very interesting is that as this is added, a thick white clumpy precipitate forms in the flask. This definitely isn't salicylic acid, and it's very unlikely to be sodium salicylate as this is very soluble in water. Since methyl salicylate has a phenolic hydroxyl group on the aromatic ring though, it's quite possible that this is acidic enough to react and form the sodium salt in the same way that phenol does. So we're guessing that this is what's forming here as an intermediate. We've now set up a reflux condenser on top of the flask and we'll start heating to reflux temperature. Remember that methanol is also produced as a product of the reaction and this is toxic. So don't do this in an open beaker or flask without adequate ventilation. And you're dealing with a hot strongly alkaline solution, and nothing is worse for causing ground glass joints to seize up. So use plenty of grease on your apparatus to safeguard against this. Okay, the mixture is starting to warm up now, and the precipitate is becoming less thick and seems to be dissolving into the mixture. We've got the reflux just starting up. To get a more efficient heating, use a cloth of aluminium foil around the flask which will trap the air at the bottom and enable better heat transfer.
Ay, 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 ay.